Hello everyone and welcome back to the Numpy crash course. In this video we will be going over the basic concepts of Numpy and some basic functionalities of Numpy by creating some 1D arrays. In the previous video we talked about what arrays are and why they are used. So if you haven't watched that video, please make sure to go watch it. The link will be down in the description. So without wasting any more time, let's get right into the video. Simply put, Numpy arrays are just Python lists with added features. You can easily use Numpy by importing it with import numpy as np. After you have done that, in Google Colab, you can simply run the cell. After the cell has finished running, then you can add another code block to start using NumPy. It's actually fairly simple to make a NumPy array. You can just use the np.array function, which takes in a Python list as its argument. This function actually has quite a few keyword arguments, but the most common one is dtype. You can use dtype to manually cast the data type of the array. And there are numerous different data types I can set this keyword argument to. But if you want to find more, you can check out the link in the description below, which has documentation to the data type keyword argument. But for the purpose of this video, I'll just be keeping the dtype keyword argument to integer to keep things simple. So now let's see this in action in Google Colab. Like I mentioned before, you can make an array simply with the np.array function and passing in the values using a Python list. So here I made an array using the numbers 1, 2, and 3 and setting the dtype to an integer. After doing that, I'm just going to use the print function to view the array I just created. You can also use the represent function or the repr function to have a better presentation of the output. Now just run the cell and congratulations, you made your first array. Wasn't too hard, right? I know we were only supposed to make 1D arrays in this video, but it feels way too simple. Let's take it to the next level by making a multi-dimensional array, and this can be done by creating lists separately inside of the np.array argument to specify the different dimensions of the array. So in this case, I will make a 2D array with numbers from 1 to 6 and specify the dtype to be an integer, and then use the print function to view my array. After you have done that, just run the code cell, and there you go. You just made your first 2D array. Now that we made some simple arrays, I want to go over a key concept that you should know when working with NumPy, and this concept is called upcasting. Upcasting occurs on arrays with mixed data types, and if the array has mixed data types, then the array will upcast to the highest data type of that array. This might sound a little confusing, but here's a simple way to understand how upcasting works. If you have an array that contains floats and integers, then the data type of that array will upcast to a float since that is a higher data type. Now, let's see this in action in our Colab. So here, I'm going to make an array that contains integers, floats, and strings. Remember that dtype is not a required argument, so without setting it here, I'm just going to run the code cell, and as you can see in the output, all the values are upcasted to a string because the highest data type in this array is a string. And the U32 just means that the data type is a little endian 32 character string. You can find more about this on the NumPy documentation. You can also change the data type of an array using the asType function. And this function only takes in one required argument, and that is the data type you want to convert the array to. The asType function is pretty straightforward to use. In this example, I created an array that has 3 integers, but I needed these values to be floating point numbers. So I just use the asType function to set the new data type for this array as a float. Let's see how this works in Colab. In Colab, I will create a quick NumPy array with integers only. And I'll print out the array I just made to see what it looks like. After, I'm going to create a new code cell, and then just like the example I showed you, I'll use the asType function to change the data type of the array into a float, and then use the print function again to view it. As you can see, that data type for this array has converted from integer to a float. You can also get the specific data type by printing its keyword argument, just like this. There's one last thing I want to talk about in this video, and that is Pies Placeholders. So when we don't want an array to contain a specific value at a certain index, we use np.nan as a placeholder for that location. But one thing to note, when working with np.nan is that it can take an integer type. Let's see how np.nan can be used in Colab. So, in our Colab, to show how np.nan works, I am just going to quickly create an array that contains 1, 2, and np.nan as a placeholder for the third value. And then, I'm going to use the print function to view my array. And in the output, the placeholder comes out as nan, which simply means not a number, and just represents itself as undefined. And one more thing to note is that the numbers in the output are all floats. Like I mentioned before, np.nan can't take an integer value. In this video, we learned about how we can make some simple arrays and some functionalities we have with those arrays. In the next video, Hamad will go over some more basic concepts of NumPy. The lesson material for this tutorial can be found in the Colab notebook in the description. But make sure to go review the things we learned in this lesson. So as always, make sure to subscribe and hit that like button. And if you have any questions, feel free to drop it in the comment section below. And I will see you next time on Coding Matrix.